Okay, so today what we're going to do is we're going to look at some applications using parabolas and quadratic equations. So in other words, word problems. Okay, most of these you're going to be given some visual representation of an item and then they're going to ask you questions about it. So I'm going to go through these. As we go through these, I'm going to give you some hints and remind you of some of the stuff. Remember, I kept talking about those ones where they give you all the little words at the very beginning and you fill in the blanks? And I kept telling you that all of those pieces are really important, and you're going to see why today. So those of you who are like big picture thinkers and just didn't want to deal with those little details, you're going to see why I made you anyway. Okay? Because that's the kind of thing that you're going to need to use to be able to make these work. But you know a lot more than you think you do about these. Okay? So, let's think about it. I mean, let's just look at some of them. So we're just going to go to the book and work on them. And I'm going to change the color of the pen, too, because it doesn't work very well for this. Red's everybody's favorite. All right, so here we go. Classic. All right. A feature of a ladies, come on. A feature of a skateboard park is to be modeled on a parabolic shape. Parabola, right? It has a width of 10 meters, and its greatest depth is 0.5 meters. Okay? So, what we have here is part of a parabola. Yeah? And some key features that work for all of these problems is to think about where it begins and where it ends. We use the ground like the x-axis. Right? So where it begins and where it ends are very important parts. So remember, we were talking about those integral points. And two of the most important ones are the X-Intercepts. They are almost always a key feature of these word problems. Sometimes they'll give you a word problem where they're not, but most frequently, that's probably the most important integral point you can find. And if you think about, if it starts here and ends here, and that distance is 10 meters, then that tells you that this intercept is at 0, right? You've gone nowhere. They won't tell you that, but you need to know. So like if I was hanging a rope between two poles, the first one side of it would be 0, and the other side would be whatever distance they give you. In this case, they say it's 10 meters apart. So this other intercept is 10. Pretty straightforward? But you might not think of it like that unless it's been pointed out to you. Okay? Now, we also know that if you go halfway between those 2 points, you get the, what is it called? It's part of the vertex. Which part? The X value. Yes, you get the axis of symmetry, exactly, which tells you the X. So the X value of the vertex. So in this case, the vertex is halfway between 0 and 5. In other words, the X value is going to be 5. Pretty easy to work out, yes? Okay? And the vertex is another one of those integral points that they kept beating into you, right, as we went through these. Now, we need the Y value. Well, the Y value is how far up or down it is from the X-axis. And since we're using the ground as the X-axis, it tells us that that this part is how far down? 0.5. Negative. Right? And it's down. Right? So there we now know the vertex. Okay? So we know a lot of pieces about this puzzle, even though we didn't know that we did. Okay? You can put a lot of pieces in. Okay? So let's look at the question and find out. So it has a width, blah, 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 blah. Let's find out what they want. If the ground is represented as the x-axis and the y-axis is at the left edge of the curved surface, now that's handy to know. You always use that beginning point, that left side, as the y-axis. No matter where else anything else is, use that beginning as the y-axis, because that makes this point 0, right, every time. So always do that, okay?
Why can't you take the middle 0 to make the y intercept point is 0, like 0 and 5.
It'll make your life more difficult. Because we're talking about measurements here. Do you have negative measurements? Not really. So it'll make your life a lot more difficult. I see your logic, but don't. Always use it. Always use this edge. Okay?
How long does it take for marks to get that from marks?
Yeah. Oh, a week or two or something. We try to get them quite quickly.
Yeah.
Okay. All right. So if the ground level is represented the x-axis, the y-axis is the left edge, calculate the equation for the parabola. So we already know the two intercepts, right? So our intercepts, so we'll use that intercept form. So y equals a times x, and our first intercept is at 0. So x plus 0 is just plain old x, right? And our other one is at 10, so that's x. Now it's at 10 to the right, so what? X what? Plus 10 or minus 10? Minus 10, because it's a positive 10 over here, but when you stick it in with your x, remember it always changes the sign? Okay? All right? Then, we need another point in order to be able to find our a, and this one's going to have an a. Look how wide that thing is, right? So we need another point to find our a, and we can't use the y-intercept. Why? Because it's the same as one of our x-intercepts, right? It'll just give us right back where we started. It won't work. So instead, we'll use the vertex, right? Which we just said was the point 5, comma, negative 0.5. So just some of those integral points will give you enough to be able to find the graph. So in place of x, I'm going to put a 5. In place of the y, I'm going to put negative 0.5. So negative 0.5 equals a times 5 times 5 minus 10. Does it make sense? Right? We're just using that X-intercept form of the equation. Okay. And then it's just a matter of solving the equation, which you see they've done there. Multiply that out. 5 times negative 5 is going to give you negative 25, negative 25a. You divide both sides by negative 25, which gives you a equals 0.02. And so that is your a value that goes in front of your y. In front of your x, I'm sorry. Right? So you know more about these drawings than you think you do. But the key is to make this one always your y-axis so that you get that 0 point right there, really important. And remember that anytime you're exactly halfway between those, that's the axis of symmetry, which is the x value of the vertex. Okay? And if they tell you how deep it is, you also have your y value.
What if they don't tell you what it is?
Then they've got to tell you some other stuff so we can figure it out.
Okay.
Right? They may not come right out and just draw it on the thing here, but they may tell you something about it. It's half as far as the width, right? So in this case, half would mean that's 5 foot deep or something like that. So they have to tell you enough information to be able to answer these. Now the next one is a little weird because it doesn't have a drawing. It doesn't look like a parabola, but we know that it's the equation of a quadratic because you have an x in front of another x there, so that would give you if you multiplied it out, you would end up with an x squared, right? So it says the weight of apples that Morris picks in his orchards follows a quadratic model. Oh, well, they also kind of tell you it's quadratic. Y equals, and there's the equation, where y is the weight in tons that is picked on any day, and x is the number of days since he started picking. For how many days does he pick apples? Okay? Now, let's just think about what we know. If we were going to graph this is x plus 0, isn't it? So that tells us at 0 we have an x-intercept. X minus 16 gives us another x-intercept at positive 16. Since this is negative, what does this parabola look like if we were going to sketch it? It's downward, right? So that tells us that if we're over here, he's picked negative apples. Can that happen? So the graph can't even exist over there. If he goes past 16, he's picked negative apples. Can that happen? No. So in other words, our graph can only exist between 0 and 16 because you can't pick negative apples. So what is the maximum number of days he picked? 16. Because if you go past 16, you go down below the y-axis, so you're picking negative apples. And that can't happen. Okay? All right? Now, can you tell me, on what day did he pick the most apples?
The vertex.
The vertex, exactly. The vertex is the highest point. And it's halfway between 0 and 16, so the x value is what? 8. Now, does it tell me how many tons of apples he picked? But do I have a complete equation with only x's and y's in it?
Yeah.
So could I use that equation to find out how many tons of apples he picked on that particular day? By simply replacing x with 8. Because we're not looking, in other words, we're not looking for an a, so we don't need an x and a y. We just need to replace it with x and find the y. So y equals negative 0.10 times 8 minus 16, and then you'd work it out.
Would you multiply 8 by negative 0.01 first?
It doesn't really matter, because if you got three things multiplied together, right? So 8 minus 16 is going to give you negative 8. So you have this times this times this. So it doesn't really matter which one you multiply together first.
Okay.
Right? Always do inside the brackets first, though. Simplify that, and then you just multiply in any order you want to. Somebody want to stick that in your calculator and tell me what you get when you multiply those three things together?
I wish I lost my calculator. I brought my calculator for the first time in weeks.
Woohoo! Okay, so you know a lot more about a parabola than you think you do. So think about it. And think about that axis of symmetry. You're going to use it constantly. And it's always simply halfway between the 2 points, the two X-intercepts. All right? So super simple to find, critical to your work. Yes?
This is Intercept Form. Oh no, but it's not a form.
This? Yes. Right? Okay.
So I know some of the other classes are doing it, and I don't know if it would be useful for our class to they take a practice MCAT or like
Here's another question they ask you a lot. Maximum height of the arch. Where's the maximum height always going to be?
The highest point.
The highest point, which is the vertex. And which one of those numbers tells you how high? The x or the y?
Why?
Yeah. So that's just the y value of the vertex. So even though they ask you for these questions in a different way, you know this information. See what I'm saying? Right. So you'll plug in 1 in the equation and solve it to find the y value. And that'll give you the number. Okay? It's y equals. All right?
What is this unit called?
Okay.
Application and what? Parabolas.
Applications of parabolas and quadratics. Okay. Now, I'm going to stop the recording and let you work.